everybody, especially you, Carlos de la something de Vega. I don't know how to pronounce your name. But yeah, this is a quick proof by induction. It's the proof of the sum of the first n squares because this was requested somewhere. I'll just put it in the because why not section of my channel. This is where I put any requests. Okay, so basically we want to prove that the sum from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6. And okay, so we do this by induction because I'm not cool and don't know any other way to do this. Base case. This is when n equals 1, so we have to say that 1 squared equals 1 times 2 times 3 is 6, divided by 6 is true. So yeah, this is true. And so the base case is correct. Now we have to prove it for n plus 1. Inductive step. I don't know what to say. Basically proving it for n plus 1. So, sum from I equals 1 to n plus 1 of I squared is equal to, via the inductive hypothesis, this. So n times n plus 1 times 2n plus 1 over 6 plus n plus 1 all squared. And now we'll combine this to make it one fraction. So this is equal to n times n plus 1 times 2n plus 1 plus 6 times n plus 1 all squared all over 6. And now the trick here is to factor it nicely so that we get the exact thing that we want. So this is equal to, well, we bring out the n plus 1 first, so n plus 1 times, well, we have n times 2n plus 1 plus 6n plus 6 all over 6. And hopefully you see where this comes from. Basically, actually I'm just going to distribute this as well. So we'll have 2n squared plus n plus 6n plus 6. Basically, I took out an n plus 1 from everything, so we have n times 2n plus 1, so that's the n squared plus n. And then we have 6 times, well, just n plus 1, because we brought one of these n plus 1s out to the outside, so we get 6 times n plus 1, which is 6n plus 6. And then move this over 6. And now, this equals, well, n plus 6n is just 7n. So we have 7n plus 6. So we have n plus 1 times 2n squared plus 7n plus 6. And now, this equals n plus 1 times n plus 2 times 2n plus 3. Okay? Over 6. So we have the n plus 1, and then we'll just check this quickly. N times 2n is 2n squared, and then n times 3 is 3n, and then 2 times 2n is 4n. 4n plus 3n is 7n. 7n, yeah, and then 2 times 3 is 6. Perfect. Now, this actually proves it. Okay? And why? Well, here, if we just plug in n plus 1, plug in n plus 1, we'll get that the sum from I equals 1 to n of I squared equals n plus 1 times n plus 1 is n plus 2, and then 2 times n plus 1 is 2n plus 2, plus 1 is 2n plus 3. All over 6, which is exactly what we have here. And yeah, this is the proof. There you go. You're welcome. Bye.